Okay, first step is always the same. I'm trying to find the rate of change. So I want change in y divided by change in x. Question? Raise your hand if you know what rule we should use first. So every problem is the same. All you do is look at whatever d dx you have. So I have d dx of this. And you go down the rule sheet, you look at the left side of each rule, and you try to find a rule that looks just like what you have. D dx. Raise your hand when you can see the rule that fits. Talk to each other. Hands up. What rule? Cal.
Subtraction.
So, I go right to here, my add subtract rule. I see, yeah, I've got an f minus a g. So one derivative becomes 2. Oh, we can shorthand this now. This is just f prime. Okay, once you have used a rule, your brain should reset. And you say, I'm starting over from the beginning. Now I have 2 problems to solve instead of 1, but they're smaller, so it's easier. How many knew that before you did it? 2 points. 3 for Tal. Okay, I'm writing what rule got used. You don't have to write that. That's just for notes. So, questions? You need me to elaborate? You can see again. So now you just look at this piece. Hands up. What rule gets used? Show me your hands. What rule do we now use? And this is the process we go through over and over again. So now we're looking at just this little piece. We've got to identify what rule gets used. Let's go, Camden. So come over here to the power rule. So Camden, if we're using the power rule, we have to identify n and g. So what's n?
3.
And what's g? Good. How many knew it? 2 points. 3 for Camden. So next line says this. Three x, 3 subtract 1, dx over dx. Question? Make sure you write the dx over dx. That will cause errors in the future if you don't remember to write that. Question? Oh, please, wait.
So is the dx over dx being multiplied by the 3x, 3 minus 1?
Mm-hmm. Well said. 3 points. I've got 3, so 3 factors. 3 multiplied by x squared, multiplied by dx over dx. Please.
Can you just explain where you got the 3x?
Here?
Yeah.
So let's back up. Did you feel okay that we needed to use the power rule?
Yeah.
Good. So tell me, Gavin, therefore, you have identified g of x as being what?
3.
No. So g of x is actually the x. That's this. Do you see it?
Yeah.
And then the n is 3. You with me?
Okay, yeah.
Cool. So now what happens is we're going to take, you see it now? Yeah, we take this away, plug in there.
Okay.
3 points. There you go. Oh, please.
I have a question about the, so I understand all of that. And we were talking earlier about how dx over dx is always going to be 1 unless it's 0. So how do we know when it's going to be 0 in order to prevent from
Gotcha.
making that mistake.
So what I was actually trying to make sure you understood is this. Throughout calculus all year long, we'll encounter this type of situation a lot. Sometimes we'll see this. Points for the whole room, actually. So raise your hand, please. Is this always equal to 1, or is there an exception? Hands up, come on. Is this always equal to 1, or is there an exception? Stephen?
Exception
And what's the exception?
when x equals 1.
Good. So here, if x equals 1, this whole thing is undefined because it's 0 over 0. Otherwise, for all other x, so as long as x doesn't equal 1, this whole thing is just 1. How many knew it? 2 points. 3 for Stephen. Do this one. Is that ratio always equal to 1, or is there an exception? Look at my hands. Is that ratio always equal to 1, or is there an exception? Don't take points unless you raise your hand. Let's go. Ray?
It's always equal to 1.
This one's always 1. Using real numbers, we don't do complex in this class.
Yeah.
There is no x value that will cause this to be 0 over 0. So this one's always 1. No exception. How many knew it? 2 points, 3 for Ray. Dx dx means you've got some sort of function, you're at some point, and then you change the x coordinate by an infinitesimal amount. So you change to a different x coordinate. Well, that change is always something because it's an infinitesimal change. The change isn't ever going to be 0. So that's why this is always 1.
Okay.
That makes sense.
Yeah.
Other questions? Please, Megan.
So is dx over dx a constant then?
Yeah, it's 1. It's a constant.
Oh,
Dx itself is not.
right, but dx over
But dx over dx is definitely 1. And always will be. Good comment. Other questions? Really good. Hands up. What rule gets used here? Hands. What rule do I use here? Let's go, Sarah. Power rule again. So what's G and what's the N? -5.
Oh.
No worries. You good? How many knew it? 0.3 for Sarah. So this becomes, bring down the -5, x, -5 subtract 1, dx over dx. Make sure you write the dx over the dx so I don't have to break out the stamp. Okay? Very good. Questions? Thomas, please. Oh, so from this step to this step, these two terms were subtracting, so I had to have a subtraction. So when I kept writing, I used the power rule to change this. So here's the subtraction sign, I still need it. When I use the power rule here,
Oh, yeah.
you see it now? Good question, 3 points. Anybody else? Cool. We're done. F prime is simply 3x squared. Negative is positive. Perfectly valid answer. I believe the back of the sheet probably says this. Question? Please.
Can we have a negative exponent like as our final answer?
Yes. Some teachers say things like, you can't have a negative exponent. No, they just don't want you to.
Okay.
Yeah, there's nothing wrong about it. In my experience, in my work experience, it kind of just varies. In some situations, you're trying to model a circuit or something, you actually want to think of that as negative. It's easier to understand.
Okay.
But in other cases, you might want to think of it this way. The AP test knows that, so they will have questions where the answer will be in this form, and another question might have the answer in this form. So they're checking to see if you know that you can do either. So, like one question won't show both. Does that make sense?
Yeah.
It's 3 points. Anybody else? Nice. Next one. Save that.